All right, good morning, everybody, and thank you for inviting us to present today. So my name is Joshua Auld. I'm the group manager for the Transportation Systems and Mobility Group within Argonne National Laboratory, and joining me is Gurumurthy, who is our technical lead for shared mobility modeling. And I'll present today on an overview and some example results of a lot of the work we've been doing with our tool Polaris on modeling transportation systems. But first, to go over a little bit of the motivation for the work and the tools we've put together, a lot of this comes out of the recognition that mobility and energy are quite broad topics, and that these in fact cut across many different sectors. So we have transportation, but also buildings, energy grid, land use, traveler, human behavior, freight and delivery systems, and many others. And you can see that the breadth of these issues is critical, especially when we're trying to tackle such large-scale and challenging problems as national decarbonization and setting net zero goals. One of the key limitations in a lot of the work being done in many of these areas is that approaches in one sector may not be optimized to account for changes or knock-on impacts in other sectors, or in the worst case, approaches may conflict and work against each other. One example could be mass vehicle electrification and renewable energies generation being done simultaneously don't actually align as a particularly effective joint solution. So there needs to be strategies around grid management, generation strategies, storage, and so on to enable these things to work together. So therefore, we identified that a holistic approach to addressing transportation, but many of the other sectors it's connected with as well, is required to achieve a lot of the fairly aggressive goals that have been set. And this is why we have been working on developing a multi-level, multi-fidelity modeling and simulation framework to understand these relationships and interdependencies between different systems. So this work really resolved itself into the implementation of a workflow. And this was done through the last 3 to 6 years of funding as a part of the Smart Mobility Consortium, which came out of a lot of the work under the U.S. Department of Energy Energy Efficient Mobility Systems Program. This was a large project, multiple national labs. So, we worked with 3+ national labs, over 12 universities, and connecting many different tools to develop an end-to-end workflow, and flexible workflow that enables us to look at system-level exploration of decarbonization strategies and energy efficient strategies and mobility productivity strategies for the transportation system. Now, this is a workflow that runs all the way, at the far end, from infrastructure deployment, long-run land use changes, vehicle market evolution, flowing through the center of the workflow in agent-based transportation system modeling, where we're looking at how travelers, goods movement, and system controls interact to realize a mesoscopic representation of transportation systems, all the way down to the micro level, whether that's microscopic traffic flow modeling, detailed vehicle modeling, and multi-vehicle controls. So how all these things come together to generate vehicle energy consumption, but also many of the other metrics that are of interest to our sponsors and stakeholders as well, whether it's the traditional mobility measures around congestion, delay, hours traveled, miles traveled, and so on, or things like cost, energy, emissions, and more, whether how all of these technologies and policies that we're exploring affect equity, accessibility, and so on. So as I mentioned, this is a large-scale workflow running from the high-level, long-run infrastructure change down to the day-to-day and micro decisions. So this requires a lot of tools and a lot of data, where the work has been to connect these and to create a holistic and coherent system of models to generate this workflow. So why do we feel that this workflow is unique? So there are a lot of examples of model workflows and other tools in the transportation sector and other sectors. What makes this tool unique, at least from our perspective, is the inclusion of a full-featured activity-based model for passenger travel, but also for goods movement and other operators in the system as well. So we include the freight shipments, we connect it to vehicle energy consumption, which greatly expands the type of analyses and metrics we'll be able to generate. And all of this is done through a full integration between the demand, network assignment, traffic flow, and other movement aspects of the system. So it's not a series of disconnected tools with a loose coupling. It is one consistent and holistic representation of all of the movements, in continuous representation of all the movements in the system. We've also connected this through that workflow development into larger scale tools, modeling land use changes like urban sim, vehicle energy consumption through autonomy, and many others. So it's this full integrated agent-based implementation that makes that provides a unique set of capabilities when we're doing studies for many of our users and stakeholders. All of this would not be possible without the significant investment and effort we've put into enhancing the computational performance of the tool. So as I mentioned, it is a fully agent-based platform where there's a core underlying agent-based discrete event engine model or discrete event engine software that everything sits atop. That's implemented in a high-performance C++ code base, which allows us to run very large-scale models up to 100% of agents for a large city like Chicago. Can be up to 10 million agents and even larger for some of the deployments that we have in fairly reasonable runtimes. And it's also natively available on cross-platform and especially relevant there on Linux HPC clusters, but also cloud platforms and even high-end desktops if the model is small enough. So all of that works together to enable the features mentioned there on the left side of the slide to generate this workflow. Along with that, so outside of just the Polaris model code itself, it is, when we distribute Polaris, it is a set of tools, data formats, and processes for generating these transportation system simulations. So it's not only the simulator code, it's also a lot of Python-based tools for setting up study workflows, for editing inputs to the model. A lot of this is done through a QGIS-based network editor and file generator. It's a set of open data standards, many of them implemented in SQLite, but also other open standards for getting model inputs and putting it into the format that the Polaris model needs to run. And it's also, additionally, there's a lot of post-processing analysis and visualization capabilities that come along with this. So it's not just the model, it's a federated tool set to build and run studies. Quickly, just example some of the inputs. I think all familiar with the type of data that flows into these things, whether it's traffic analysis, zone and location and parcel, or even building level data. The many household surveys on standard diary, but also advanced surveys on decision making and trade-offs and adoption of new technologies and so on. Vehicle distributions around where different vehicle registrations and powertrains and what type, what segments of vehicles. So all of this flows in to generate our populations and the physical environment when it's combined with the network and mode modeling inputs that Polaris uses to simulate. So this is just an example of many of the traffic data, network elements, transit networks, and other network data for the various modes that flow into the Polaris model. And there's always capabilities to expand this as well. In addition, we also have transportation systems. So there's controls represented as ITS elements, whether that's signs, whether that's a management center or flexible lanes or many of the other technologies, along with more advanced research-based controls like through roadside units and vehicle-to-vehicle and vehicle infrastructure communication. So there are facilities to ingest all of this data into the model. So along with that, the reason we provide all of these supporting tools is there's a strong effort to get this model out of just our hands and into the hands of partners that actually build and run these models. So Polaris itself is currently it has either 14 operational and planned models, so one that's being implemented for Honolulu, missing from this slide, but there are many models in various states of readiness that are being deployed. Our home model, I guess, if you will, is the Chicago. That's the one we've been working on the longest, and we have extensive partnerships in the Chicago area, both on the agency side, on the university side, and other partners. But many of the other models that are at a similar state of readiness, especially for Austin, Dallas, and Atlanta, where we have direct partnerships with some of the MPOs in the area, and many different regions across the country, working either with industry, with local universities, or in many cases both, to develop models, ranging from the smallest scale on Greenville, South Carolina, all the way up to the Los Angeles model, which I think has over 18 million agents in the simulations we're representing, and even a statewide model that's being implemented for Indiana in partnership with Cummins Inc. and Purdue University to look at electrification of travel corridors through that region. So fairly extensive deployment, and we're always happy to expand on these and bring new model areas into the coverage of the Polaris model, which is currently between the model shown here is about 20 to 25% of the population of the country. So that's at a high level motivation. What is Polaris? And I'll go a little more into detail now into how the functionality of Polaris, how it works, what it's comprised of, and the different capabilities and components of the tool. Overall, the Polaris System Simulator looks a bit like this, that it is a representation, an activity-based representation of individual agent decision-making, running from the long term all the way down to individual within day and minute-by-minute decisions. So long-term choices, as was sort of introduced on the workflow slide, come from land use modeling or the inputs to set where the people or where the agents in the model live, where they work, which vehicles they own, which technologies are available on those vehicles, and so on. And then that flows down to form the constraint set around their midterm choices, so the more routinized activities about work schedules and school schedules and so on. And that all flows into the within day, so the true activity-based portion of the model where we have all of these agents continuously generating activities, planning those activities in relation to other plans for the day that they have, other plans that their fellow household members have, and schedule availability. So there's this continuous loop of generating, planning, scheduling, and even executing those activities. So as we generate the schedule, they go onto the transportation system. They have the realization of that movement, so it either takes the time that was expected, or it's slower or faster, update the schedule, and continue on with the day. So the co-simulation of all of these agents in the system interacting and competing for resources, whether that's a seat on the bus or space in a link, is what generates the outcomes. So the realization of the macro characteristics of the system in terms of congestion, energy use, and so on. And I should mention here, so this is a depiction of this system from the individual traveler perspective, but we have the same type of workflow and sequence of decision making, whether those agents are passengers, but also if they're involved in freight and logistics. So if they're companies in the freight system, if they're transit operators providing transit services, if they're TNC operators, distributing their vehicles and matching rides. So there's this higher level depiction of the choices and interactions for all of these. So this is not limited to an agent-based perspective only from travelers. And the purpose of this and why to have these different levels of decision making and having such detail on decisions is to look at and be able to explore many of the impacts that smart mobility or future mobility or new technologies or policies, whatever we want to call it, whatever the intervention happens to look like, we want to say we can address these that can't otherwise be addressed with existing travel dynamic modeling tools. So we want to capture the effects, long-term choice effects, and how changes in land use patterns and vehicle and technology and adoption models are going to influence long-term choices, how that will flow down into individual activity planning choices. So if I have an autonomous vehicle, does that change where I live, where I work? Does it change the modes I chose? Does it change who I choose to travel with and how I schedule and so on? So there's all this flow down of decision making that falls into at the agent level, but also on their activity realization level as well. So what is the impact of having an electric vehicle? How does that change how I need to organize my day and when I need to schedule charging decisions, for example? How do changes in tactical driving behavior from new vehicle technologies influence traffic flow, and how does that flow up to my decision making? So there's all these series of interrelated choices that are represented in the model itself. At a high level, the Polaris model, I think kind of just went through that, but does represent activity generation, activity planning, scheduling, and execution continuously throughout the day through a series of statistical, heuristic, and discrete choice models. And again, this is only from the traveler activity planning perspective, but there's this sequence of steps they all flow through and continuously update in terms of making their decisions. I think uniquely in this system, we also implement that agent-based perspective and agent-based sequence of decisions, interactions, and adaptations on the dynamic multimodal traffic assignment and simulation side as well. So we have a fairly detailed personal-based time-dependent intermodal A-star algorithm that is used to route individuals through the system, and that's independent of the mode chosen, and those can be multimodal trips and so on. And that's has a weighting characteristic between previous observations, current system information that's being passed through any whether app-based navigation or system-level controls, as well as prospective route planning and route guidance. So all of these are taken into account at the individual level, and individual route decisions are made. People travel along those routes. They continuously update those routes based on unexpected or changing conditions, and complete their trips to give us the realization of the KPIs of interest there. And that is continuously integrated with the transit, the transportation simulation. So whether that's movements on a road link, whether that's moving through the transit system on a train or a bus, or even just going to a dock facility to grab a bike or an e-scooter, all of these are simultaneously updated in terms of their link performance and edge costs, as well as feeding back continuously into the route choice decision. So this is agent-based dynamic multimodal traffic assignment that we've implemented here. That leverages a lot of work that was done on the traffic flow simulation side. I won't go into too much detail on this, but we do have an implementation of the LWR model that's been extensively updated to allow for intersection controls and individual vehicle follow and speed spacing behavior, basically. So by reparameterizing this model into a Lagrangian coordinate system, so basically transforming the fundamental traffic diagram from a flow density to a speed spacing relationship, and then having different relationships for each vehicle class. So it's a continuous differentiation of how the vehicles behave. We can represent the impact of a lot of new vehicle technologies, which was previously difficult to do in a mesotype, non-complete micro simulation implementation, while still maintaining a lot of the speed and performance characteristics of a meso simulation. I mentioned previously about this time-dependent intermodal A-star, so I won't go into too much detail on that. Just to say it's a fairly detailed route choice algorithm that accounts for different information and learning strategies across different modes within the system that's continuously running in the background, and leveraged for our agent-based DTA convergence algorithm, where we're running model in ABM loops, DTA loops, and trying to come to some skim convergence and other convergence gap measures to say when we've hit a stable solution in the model system. And one final point on the larger model development is we do have this land use integration. So we have direct capability to integrate with the urban sim model and pass excuse me, outputs back and forth between urban sim and Polaris in terms of the updated populations and updated population decisions, network performance and travel times. And we're currently working on a few research projects with them to pass more individual, even accessibility or utility-based metrics to say where do individual households choose to live and work. But there is that capability of working directly with the urban sim model or other land use models as needed. On the freight side, so as I did mention, for the overall workflow, so that was representative of the passenger travel, but again, on the freight travel, we have a similar set of agent decision-making strategies. So this is somewhat equivalent, where we go from the strategic long-run level about choices about how many, how large is my enterprise, what goods are we producing and consuming, how do I generally form my partnerships in supply chain and logistics, so who do I trade with and where do I source materials from or sell my materials to, and what assets do I own, things like distribution centers, fleet assets. So how many trucks do I own for shipping if I'm going to be involved in that, and so on. Then there's the tactical decisions, which is more the midterm choices around procurement, production, and logistical arrangements. And then the operational decisions about how do I actually schedule vehicles on tours, when do I dispatch the trucks, and how do I organize my delivery tours, and so on, and to get goods to the consumers. So the high-level cartoon flow on this side looks fairly similar to the passenger side, but we start with the firm synthesis. Those firms then generate their asset choices, and conditional on that, they have fleet and depot electrification decisions and supply chain partnership formation. So based on whether I own shipping assets or not, will influence what type of supply chains I engage in, but then we develop our supply chain connections between all of the firms in the simulation. Based on that, and for any given day, we generate the transport and logistics chain formation. So what is the path for individual shipments from end to end? And then how do those paths actually resolve themselves into tours for whether it's the company engaging directly in the shipment decision or engaging with a third-party logistics company or other shippers? What are the tour formations for the movement of that goods? And then again, ultimately resolves itself into traffic simulation, as movements through the system competing with space with the passenger side. So touched on that briefly in the last slide and in the passenger side, but we do extensively handle electric vehicle deployment and charging simulation. So we model the EV consumption. So as different agents or shippers are moving around, either traveling or delivering in an electric vehicle, we model continuously the consumption, the state of charge of that battery, and what effect that has on the travel day. So does it occasion the need to go to a recharge to do an EV charging trip? Do we wait at the charger or go to a different charger if it's congested? And even larger scale decisions. So if we step back to that strategic level, based on current demand or projected demand, where do we place chargers to get optimal performance, either revenue or minimize deflection time or minimize wait time, depending on what the target function happens to be. But all of this is modeled directly in Polaris using an ML model for vehicle energy consumption that's connected, co-simulated with the Polaris model. There's also a battery charging model. So we do, again, as I mentioned, calculate link by link energy consumption, and then based on that, engage in charging decisions and simulate the charging event. So a traveler can decide to charge or a truck can decide to charge. And then it needs to engage in the search for the nearest charger, see how the travel to that charge aligns with the rest of the activity plan for the day, modify that activity plan as necessary, and then engage in the charging event when the time comes for that. And this is extended to shared fleets, transit fleets, local delivery fleets, and business-to-business fleets, and so on. So we, example here shows how we do that for the shared fleet charging behavior, but again, the same decision-making can go into updating transit schedules. So we have several studies we've done on bus electrification, which I'll show an example on later in the slides here. But all of these fleet control and fleet strategic level decision making can be influenced by the availability of electric vehicles as well. And just very quickly, what makes that available and makes that possible for us is our integration with the Autonomy Vehicle Energy Consumption Performance and Cost tool. So Autonomy is a US DOE supported and preferred tool for vehicle level simulations. This has been developed over 25 years. So this is a long-running tool licensed to many organizations, including many of the automakers, different universities, other companies, component makers, and so on, to do model-based design and evaluation of vehicles and an assessment of the energy consumption and cost for different powertrain configurations. So this is a tool that goes into a lot of the CAFE regulation, for example, to identify what are current and projected future, so it is a forward-looking tool as well, performance characteristics of different powertrain configurations. So on top of that, we have built an AI-trained version of this model, which can take for a more limited subset of vehicles. So it's not a full design and analysis tool, but for a representative characteristic set of electric vehicles, we have this model running continuously through TensorFlow connected with Polaris to simulate the energy consumption for all of the EVs in the system. So that, I don't know, maybe pause for questions there. That's an overview of the Polaris tool, and I'll just go quickly into a couple of case studies if there are no questions from the audience.
I think you can answer one question on the history of Polaris and whether it was based off of transims.
So Polaris was not based off of transims. So Polaris started as an outgrowth of the transims research and deployment support project from Federal Highway. But this came about, so it does share commonalities with transims data formats. So since we were the team supporting a lot of the deployment of TransSims to various public agencies. We use that as a start point, but none of the code base for Polaris or solution algorithm, so nothing deployed in Polaris shares any commonality with TransSims. It just started out of the same program.
I think someone's raising their hand.
Sure. Yeah. If you call those out, because I can't see them with my shared screen.
That's me, Alex from Oregon Department of Transportation. So I don't want to jump ahead. If you're talking about case studies now, maybe calibration, validation will be coming up. But I guess one of the things in my mind is just this all sounds very good. But I think from our experience, the theory and the coding is really only like 10% of the workload. Like 90% of the work is in, like Becky's had a lot of questions around, where's the data to develop all these relationships and to validate, to check against. So 90% of the work is in ensuring that the theory and the computation is actually reproducing observable results. So I guess that's where currently that's where my curiosity is like, okay, well, basically for everything you've just listed through, it's like, where's the calibration check that trend is reasonable and that we believe it to be operating correctly?
Right. Yeah. So it's a good time for that question I got, because I did not go too much into the calibration validation, and it's more of a high level description of the case studies. So I think in general, we can say calibration and validation is always the challenge. Access to data is always the challenge. We do focus a lot internally when we're putting these tools together on, when I say we have this Python runtime and all this federated set of tools, a lot of that is focused on implementing runs to understand and providing tools to automate a good portion of this calibration process, at least to get face calibration, face validity of the models, doing automated adjustment of let's say calibrate the calibration constants based on local source data. So there is a good portion of that implemented directly, but at a deeper level, we are working on several different projects to do automated calibration of the behavioral parameters in the model based on data fusion and ML approaches to take different data sources. So we try to access as much as we can in terms of all of the sort of disparate data sets that you can access through various providers, whether that's things like INRIX or AirSage and so on. But a lot of that is helpful for calibration at some level, but it's still the part that's a challenge for us is that deep calibrate. Sorry, I'm hearing a lot of feedback on myself. Is sort of the deep calibration of the behavior parameters that come out of things like household travel surveys and some of the more detailed surveys. So some components of this, there's a large gap in terms of having the localized data when we transfer from area to area to make sure that those sort of fundamental behavior representations are correct. So that's where a lot of that work on automated statistical techniques for backing that out from fused different data sources is happening. But this is something we always have to spend a lot of time on. There's no way around that. We can make tools to make that easier, but we still have to have sufficient data if you want a model that's sufficiently, and again, if you want a model that's sufficiently representative for the purpose it's being deployed for, right? So if we want to take this and someone's interested, what happens if we have a 30% increase in EVs and what will the charging load be on the grid? Maybe we don't have to go to as level of detail. We can do a screening analysis if it's for strategic planning or something. But if we want to go to detailed project level analysis, then it's a much deeper level of planning. But probably preaching to the choir on that point.
Well, so two follow-ups. So we're not perfect about it by any means, but we do attempt to publish our calibration checks. Like is Argonne publishing the comparisons that you're doing to actual data to prove out that this is functioning correctly?
Yeah, we would usually put that in any in papers that we would write. So we've done detailed backcasting validation checks. So most of the deep validation work we've done is for our Chicago model, where we have access to a lot of, let's say, boarding and alighting on the transit system, and I think there's 500 different points where we can do the temporal-based traffic flow characteristics. There's turn movements at the traffic light. So if we have the detailed data, especially with a lot of the partnerships we have with the local transit agencies, some of the public data that the DOT is putting out on shared mobility and Uber type systems and others. In that case, we would run validation studies and I think have published those results, but sometimes it's available, sometimes it's not.
And I forget if you mentioned it, but what's the vintage and source of the travels behavior data? Like, I'm assuming a travel survey. Were you using the National Travel Survey? Were you using like Chicago's, or which travel behavior data were you basing a lot of this off of?
A lot of this is based on the 2019 Chicago Household Travel Survey and the 2009 Household Travel Survey before that, as well as travel surveys that a lot of so we do work with a lot of academic partners on collecting more one-off type surveys on interesting behavioral choices. So there was a lot of work going on with University of Illinois Chicago, for example, around micromobility. So who's adopting that? Why are they adopting it? How do those intention to adopt versus actual adoption versus actual use, and how does that change over time? So that, if we have a partner who's engaged directly because they were working as a consultant for the local DOT who was managing and the e-scooter pilot here, then we'll develop as many models as we can out of that, implement them, and then hope we can either identify behavior to localize that. If, for example, we want to do a Portland model and have it represented, is there similar data we can get from Portland? Then yes. Otherwise, we transfer the model directly and then calibrate whatever the constants would be to observable data. But it just depends a lot in terms of the phenomena that we're studying. So some have much more recent data, some have much more directly observable data in the field that we can calibrate against, and a lot of the data providers are helping with this. It's very easy to calibrate traffic counts and temporal distributions and things when you have partnership, or when you can access INRIX type data or the highway performance type data. But a lot of the fundamental behavior, and especially on the freight side, we do have extensive partnerships with different freight companies, but a lot of that is hard to observe and to calibrate across different. So you can access the data, but it's hard to have a similar type of data access across many of the different areas we deploy to.
Thanks, I appreciate it.
Yep. Any other questions?
I think one more question about whether FDA has evaluated or given feedback on our simulations and on the transit-specific simulations.
FTA, we did have a project with FDA, but that was more focused on resilience and recovery in the transit system. So they did give us feedback on that, but we get more feedback on the transit representation directly from our transit partners. So we have weekly engagements with the Chicago Transit Authority and the Regional Transportation Authority in Chicago, who are it's sort of the main transit provider, and then the oversight authority for transit. But we also work with a lot of our other city partners as well. So Murthy, I know, working with DART, working with Cap Metro in Austin, working with MARTA and the ARC team. We do try to get a lot of feedback in terms of this looks reasonable, this doesn't look reasonable, when we're representing, in transit simulations. And a lot of that helped by fairly detailed data access we can get through some of those partnerships. Okay, and actually I'll touch on that in my next slide here. So jumping into case studies. So the first one I will introduce here is actually a study we just wrapped up at the end of last year, and actually still in the process of pulling reports together and publishing out of this. But this was a large scale midterm transportation impact study looking at potential decarbonization strategies in the Chicago metro area. So this came out of extensive discussions with regional stakeholders, so engaging quite frequently with CMAP, is the local MPO in Chicago, the Chicago Department of Transportation, and then the Regional Transport Authority and the Chicago Transport Authority, to identify what are a series of highest priority regional interventions we'd want to explore to see what is their impact in terms of decarbonization and other key performance metrics. So again, mobility, energy, costs, emissions, and so on. We ended up through these discussions coming up with a set of 5 different system supply interventions, and you can see the definition here, but we were looking at congestion pricing deployment, so fixed time-based tolls on all of the highways, expressways in the region. Transit investment, where we came up with a transit increase, so increasing frequency about 40% on the suburban transit, and increasing speeds and reducing headways for 39 highly traveled CTA routes. So this was plans that are being developed by the partners and implemented in our system. Exploring connected infrastructure, so deploying connected signals at major corridors, which is an extension of a current CDOT pilot program. And then different rideshare and freight delivery policies. And what we were looking at is to see not only, how effective are these in isolation. So what happens? We can always run. What happens if we, do this transit investment strategy? What is the outcome? But the point of this study was not that. It was more focused on what are the interactions between these. So what if we did all of these at once, or what if we did just 2 of these at once? So we wanted to explore all of the possible combinations. Because of the realization, and I think the motivation for our holistic system level research is that there are significant interactions between these, and looking at different technologies and isolations a lot of times misses some of those either synergies or destructive interference that you would get from deploying multiple. So we want to identify more what are critical pathways to optimize achievement of different metrics of interest. And these were layered on top of a few different potential future demand scenarios, and that was focused around different growth rates in e-commerce and on-demand delivery, and different growth rates in vehicle electrification, from a low to a very high, 75% light-duty vehicle electrification and 50% heavy-duty, all around a 2040 forecast year. So we ended up with 192 different combinations of these scenarios and demand options that we ran through the modeling workflow to look at impacts. And what we ended up with is that the identification that the combinations of options impact many of our key metrics quite differently, in fact. So you can see sort of a high-level depiction of what the best and worst combination of scenarios is for each metric. So whether we're looking at miles traveled or hours traveled or overall energy consumption, there are not commonalities between what is not. I mean, there are a lot of commonalities, but they're not always the same in terms of what is the best and the worst option. And in fact, sometimes things that are the worst option on one metric can be involved in the best option on others. At a high level, we did find that we can increase system efficiency by about 53% through the combination of policies shown there in the 5th bar, which would be congestion pricing, TNC control policies, shift to off-hours delivery, high electrification, and significant transit investment. But that, oftentimes some of the policies involved in the best scenario for efficiency show up in the worst scenario for miles traveled and so on. So there's a lot of complexity in terms of exploring what are reasonable combinations, future plans when we're looking at developing decarbonization strategies. And just one example of what can cause that. So this is looking at the critical pathway for reduction in vehicle hours traveled. So this is an overall sort of congestion reduction measure. We find that the optimal combination in this case is congestion pricing, connected signals, TNC policy, off-hours delivery, and on-demand delivery. But there are a few interesting interactions here where if we looked at these technologies in isolation, we would miss some of the, we would miss the most optimal outcome. A lot of that especially is focused around the TNC policy. So the TNC policy in isolation actually increases to some extent the vehicle hours traveled by pushing increasing some of the use of the TNC system and pushing some of the TNC trips out of more densely populated areas in the city. It has a slight increase in overall hours traveled, but it also factors into the optimal pathway. So we can't get that 7% reduction without implementing this policy itself. So that was one of the key findings here, was that exploring policies in isolation will not allow us to identify optimal outcomes. It's critically important to understand the system level impacts of a lot of the different strategies when we're coming up with plans and trying to identify optimal strategies. there's a lot more detail on that, but that's a paper we're still working on getting out, hopefully soon, paper and report, and happy to share once that comes through. Another study we worked on with the University of Texas, Berkeley Lab, and the UrbanSim team, and the US Drive Consortium, which was a public-private partnership between some of the auto manufacturers and some of the government agencies, looked at how different vehicle technology deployments impacts the system, but not just saying let's put 50% or 90% connected vehicle penetration in 2040, but how that influences the system over time. So in this case, we ran a model of Austin, Texas, with the UrbanSim and continuous integration between Polaris and UrbanSim to say how is land use shifting along with these technologies. And the key finding here is that we see that the level 2 connected cooperative adaptive cruise control. So this is cruise control where we allow vehicles to run closer together, but with no hands-free, no driver-free driving, so that the driver still has to stay actively engaged. We can actually improve the system overall. So there is a reduction in system performance over time just due to population growth outpacing road construction in Austin. But if we deploy this L2 CACC, we can improve things slightly. But if we have an L4 CACC, so this is where people can go hands-free on the highway and not really care or focus on the driving, so reducing that driving burden, we see a shift in time valuation and people being willing to live further away from where they work and engaging in more commuting activity. So ended up reducing speed about 5% over time from the best case. So that was just exploring different levels of vehicle technologies. And one final study, we looked at transit bus electrification with a partnership with the Chicago Transit Authority. And they're actually engaging in some of this work. So, we're quite interested in these results. But we saw that conventional buses can, one of the key factors here is that the conventional buses can be driven as long as your labor law allows, but electrified buses don't typically have the range to operate in a similar fashion. So when we ran these studies, we saw, in effect, we needed about 1.6 electrified buses for every bus, even when they had a high range, because even at the highest range, it's still only about 5 hours of driving, which really breaks up the scheduling of the vehicles and especially their return to depots throughout the day. So we found that it's quite challenging to reach that 100% electrification threshold. And now we're continuing the study to look at what does it actually do on depot requirements and grid requirements when we get to these high levels of quite high power charging requirements. So I think I will leave it there and then see if there are any follow-up questions.
This is Alex again. I could keep asking questions, so I have some, but
Sure.
I'll leave it for others if they want to jump in first. So just know, so this is a warning to everyone that I will keep asking questions unless you jump in.
So I would ask a question about agent because you mentioned the agent a lot. I want the agent the household or persons or trips or schedule. So it's a very broad term in this. I'm trying to understand how do you use agent for this kind of activity-based modeling or something?
Yeah, so basically in this model, anything can be an agent. So the agents that I showed here are really the persons in the households and I guess maybe the freight operators. But the freight truck drivers can be agents. The stores that consume the good, there's receiver agents. Traffic signals in the model are agents. The vehicles can be agents if they're driving themselves. If they're not, then the driver is the agent if it's a TNC vehicle. So really everything is agent here. An agent here just means that they are individual actors in the software system that have a schedule of events that can be modified based on interactions. So, if I see something happening or someone messages me, I can change my actions, but it's all these agents which have a predefined series of behavioral responses and strategies that implement on the system to generate emergent behavior. But I don't know if that answers or addresses your question, but basically everything is an agent that gets scheduled and can.
Yeah, I think it sort of addressed that, but I had some impression previously agent was like, you don't need zones, every individual is located somewhere, a spot there, so that you don't need a zone at all. that's some advancement in terms of modeling, sort of like more macro and macroeconomic macro simulation stuff.
We still keep zoning systems because it facilitates calculations for a lot of things like the destination choice and generating travel skims and so on. But yeah, they don't route to zones, they route to specific points or buildings or parcels or whatever you'd want to call it.
Okay, thanks. That's helped me understand the difference between agent and activity-based. So it's more like when you're running the assignment, the final level is more agent-based.
Yes, yeah. At the assignment level, everyone is moving from a door to a door.
Thank you for clarification.
Oh, okay. I see a lot of Are you covering the questions in the chat, Murthy?
Yeah, I've been replying. I think somebody else raised their hand though.
Leeming?
Okay. Right, great. Thanks for a great presentation. My question is about uncertainty. For example, in the screen that you're seeing here, of course, you're reporting the average or the point estimate of the impact. How does kind of uncertainty, I was think, for example, yeah, you do have some of that. I didn't notice, but yeah, if anything you can talk about how uncertainty represented in the model, I appreciate that.
Yeah, no, uncertainty is definitely something we try to account for in the model. So anything we present, so unless we have this one was actually interesting because I put the uncertainty bounds around the network speed estimates there. So this came out of, I think, 20 or so converged iterations for each of these. So each of these points actually represents about 20 simulations after it hit the convergence point, just to get an estimate of what that uncertainty is, because it's a simulation model. So there's variance in how the probabilistic selection of any of the choices. They're all choice models or machine learning models which have inherent uncertainty. There's uncertainty. There's simulation uncertainty, just in terms of how the different choices are represented in the model itself. There's input uncertainty. So there's intrinsic model uncertainty too, right? So a choice model always has an error term and uncertainty associated with that. So we do try to explore what that looks like at a system level, just to make sure we are accounting for that. We are reducing sources of that where it's driven less by fundamental. Actually, we don't know. Like, we would never want to remove model uncertainty from a mode choice model, right? That's an intrinsic part of the model. But model uncertainty, just because we're implementing things differently in a discrete event simulation, or we're sequencing doing random number draws to change a sequence of agents. That's like simulation-driven uncertainty that we try to control for. So what our goal is to get to the intrinsic uncertainty that's uncontrollable, and then quantify that through graphics like this, where we actually show the error bars. But it's a very interesting topic, something I like to work with a lot. We have an advantage here in that we have large computers. We can run thousands of these. So I think I mentioned with this model here, we show here's best and worst, but this was based on, I think, 2,000 something final iterations, final runs of this model. So there's a lot of data to characterize this uncertainty. But yeah, characterizing it and trying to reduce it where it's applicable are something we focus on.
Thank you.
Mm-hmm.
So there's one more question.
Please.
Ali?
Hi, this is Ali Mirzakhlili from DEQ, Environmental Quality here. Question for you: there's a component, I understand, a behavioral aspect of that drives some of the decisions through the model. How do you assess things like safety, and can you simulate changes that would impact the behavior, and how would they impact, for instance, transit choice? I think it's the marker mobility, the walkings, those choices we see a lot of this when you travel survey. Is like, do you drive in single vehicle occupancy, or do you choose do you go by transit? Well, I think the answer it may be by car, because we don't have safe access to transit or don't have safe access to, and I think if we provide, how do we assess that? Is there a you know, a place here that we can you know, simulate that and say if we increased this, then this is how the behavior would change?
Mm-hmm. Yeah, that's actually a very interesting research question for us, and something we partner with quite a few different universities on. One project that Murthy's led from our side, but trying to understand these motivating factors that underlie decision making and actually accounting for that in our mode choice models it is always a focus of the work. Actually, we have an ongoing review of the mode choice model right now to try to incorporate a lot of the sort of one-off research explorations that have been done by our partners. But we do look at how does safety on the transit buses influence the choice of taking transit or not, you know, when we work with CTA, or we had a project with Clemson University and JD Power and some other, you know, market research firms to explore what safety, what comfort, what environmental factors, and so on influence your choice to share a ride with someone in an Uber or a Lyft or, you know, other rideshare vehicle versus wanting to be on your own. You know, when we work with UIC on the scooter pilot, there were a lot of, you know, I think 4 or 5 different waves of surveys that went to the people that were using the scooters to say, why did you take this scooter? How did it fit within your day? How easy was it? So I'll not to go into too much detail, but all of these like implicit factors that and attitudinal factors that influences people's decision making, we try to incorporate in the model where we think it would be useful and forecastable, right? So even if we include all that, then we have to make an assumption when we're doing a 2040, 2050 model that a lot of that won't change. So a lot of our focus is to try to get as much of that as possible, but also to capture, we really want to make sure, because I think a lot of that sprinkles around the edges, once you have the fundamental representation of, you know, the constraints that people are operating under and their fundamental behavioral characteristics, a lot of that is just sort of operating around the margins, which is what we try to represent, you know, at its most at the deepest level, like what's motivating people to make these decisions. But I think this is a topic we'd like to work on that's never done, right? There's always new data you learn about why people do things they do, and there's always new modes and new operating factors that can maybe fundamentally change that. So I think it's a great question, not a perfect answer to that question now, but something we always want to work on and strive to work on with partners.
There was one question from Becky that I tried answering. Maybe you have a better answer. So what have we forecasted as the household VMT as and when electric vehicles are adopted?
We did find electric vehicles in isolation, because that was actually one of the, if I go back here, so electric vehicle adoption in isolation was one of the scenarios in this 192 scenario model run. But just even in the basic, like the exploratory studies that went into setting up the electrification capability in the model, we do see that it has a tendency to increase slightly the travel just due to deflection for charging. It's not a huge impact to date. So it's something that we want to continue studying to see if there's longer run changes in where people choose to live and work, and what land use changes will be driven by that, and different types of charger availability. So as that will be mitigated as people have access to closer and closer charger, especially for people that don't have access. You know, access to home charging has no impact to a slight reduction because you don't have to do that occasional deflection to a gas station. But day to day, it doesn't seem to affect anything in terms of how people are traveling around the city. It may have some influence when we look at more long run choices around, let's say, extra regional travel or interstate travel. People may be less likely to do that, especially if the EV is their only vehicle. But that's like additional studies we're conducting now. Haven't done a lot of work on EV impacts on long range. That's actually ongoing studies with a lot of the NEVI deployments that we're integrating with and working with the fleet partners on to see what the impact is for different corridor electrification.
Thanks, Joshua. This graph also prompts a different question. When we're using our models, especially the statewide model, I should say, so Alex could chime in. When we see results that are like less than 1%, we basically interpret it as no change. Nothing discernible, depending on the area and knowing the model's strengths and weaknesses, maybe even 2%, not super reliable. So do you have areas like that where you're, how you interpret these results as, like the energy one, that 37% drop looks pretty, that's definitely something, but the 0.8% increase is marginal.
Yeah, these are all, so the 0.8% is marginal. So the nice thing about this is there are so many runs that went into, and I should say this comes out of statistical, okay, let me step back 1 second. So these results actually come out of a statistical analysis of all, so this is a regression model we put on top of all of those model runs. So
okay,
technically, now, is there a practical significance to 1% increase in vehicle hours traveled? Probably not. Technically, it is a statistically significant finding from the model,
right,
but very
Gotcha.
marginal. Yeah.
Gotcha.
So yeah, anything that fell below the significance threshold wouldn't be included here. But yeah, these are very borderline.
Yeah.
And actually, let me step back. This one shows it most directly. So these are the statistically significant impacts of these different parameters here. But yes, always something we're looking to say, is there actually a speed difference between any of these four technologies in 2025? I would say no, right? Those are all the same. You look a little different, but once you get out here, once you get a 4% difference, and even in this case, there was, and you can see how it tightens up sometimes. There was enough runs here where we can probably say that 0.8% increase was statistically different than this. I think the width of these was it one standard deviation? So maybe it's still a little marginal, but this one is definitely significant. But always something we want to account for.
Yeah. Okay. Thanks.
All right. Any other questions in the chat, Murthy? Oh.
Alex, did you have one or two you wanted to?
Sure. Yeah, I could. Yeah. So the question that's in my head, lots of questions. So I'm sure we can fill up the time. But I guess just kind of jumping to the big question in my mind is kind of like, well, what's the opportunity here? So I'm just curious, kind of from from your perspective, kind of like where would you like to see this move forward? I just as some context, I think you might be aware where Oregon is currently spending about $6 million on a statewide travel survey for 2023-2024. So we're going to have brand new, fresh, post-COVID travel results or travel behavior information. We're currently, designing and scoping to put that into Activity Sim, the activity-based framework Activity Sim, and working to deploy that across Oregon, across our MPOs in Oregon. We've kind of, at different points in time, we've kind of been aware of what Polaris is doing. And this does feel, it's great to see the ability to request a license. In the past, my memory of the conversations was that Polaris was something that the national labs ran, and it wasn't really provided out. So it looks like maybe it's provided out, but I put a question in the chat about, like, is there a user guide to go along with that? Like, how is it? Like, how supported is it? And we don't have to answer that question directly, but ultimately, what I'm trying to figure out is, like, well, if this is obviously a very interesting or a very exciting approach that you guys have been taking, and that you have the ability to start answering some of these questions. But from a practical standpoint of okay, well, on the MPO side, we need to be able to, like my questions were alluding to earlier, we need to be able to calibrate to existing conditions, have a defendable process that stands up in court against our RTPs and our projects and things like that. So I don't see that trajectory changing of the MPOs still needing to create like their own travel demand models that they've proved and validated, and can stand up to court challenges, NEPA challenges, things like that. But anyways, if you could just, I don't know what your thoughts are about, well, is this proposed to be a replacement of Activity Sim, or is it alongside, like partnership or side questions, or what is the hope, or this, like, the proposition, what is the opportunity?
Yeah, I think we have multiple opportunities and multiple interests from our end along those lines. So we do right now make Polaris of it. So yeah, as you saw on the website, it is freely available. We're putting together a user group where we are funded by the Department of Energy to put support tools and do the deployment support to a limited extent around the Polaris tool. So we do have operations manuals, descriptions of all the parameters, and the Python-based runtime tools that are available, and a lot of the editing tools and the open data specification. But our interest, and especially with something like the Oregon statewide model and statewide data source that you mentioned, I think would be a partnership where we look to expand. A lot of our work currently is on regional type models. We do have a semi-statewide model for Indiana, but it's more focused on the statewide corridors. We have a strong interest in doing more, seeing if we can expand the scope of Polaris to multiple regions, connected regions within, and to look at more of that interaction between the day-to-day travel decisions and more long-term, long-distance travel decisions, and how things function as a region, especially with our focus on freight, right? So regional freight, city-based or metropolitan region freight is, fine, but we would be interested in expanding to more like economic connected areas like a state. So I think Polaris itself, we are working on making it flexible how it deploys. So we presented here as one integrated tool set that is Polaris, but it can be compiled, it can be run, it can be parceled off in many ways. It could we connect activity sim through the Polaris API to the Polaris traffic simulation, network assignments, and vehicle simulation? Probably. So these are things that I think on our end would be interesting to explore. Currently, when we work with MPO partners, we don't really pose it as we're going to take this tool and we're going to do it right away to say replace your statutory approved, litigation not proof, but your lowest risk, model that you've deployed and proved out. Go ahead and throw that away and replace it with Polaris. That's not really where we see our role, and it's not our role. Like, we're not a consultancy, right? It's not our interest to go in and support these models for a bunch of different regions. But what we do like is the R&D. Can we do it? Can we deploy it for things to help answer questions that you're being asked that the current tools can't support? And that's where I think Polaris has a strong role, is to help guide where we need to go with, and maybe eventually adopt it for doing, if there is an RTP type process for statewide, to guide those decision making. Start with the lower risk, more forward-looking areas, and then build out to that. But yeah, I think that's a process of evolving to that point, and not where we'd expect to go immediately, because it is more of an R&D focused tool at the moment. Does that kind of get at what you were?
Yeah, no, definitely. No, it's exciting to hear. I forget what has come up in past conversations, but whatever it was, it's probably changed. So I guess I don't want to put you on the spot, but I'm curious. For those partnerships, you showed the map where there's multiple partnerships around the continent. Are you expecting, are there contributions being put forward? Is it something the Department of Energy has the funds to do, and it's just a matter of like sharing data and sharing expertise and having a location to deploy, like a real project that has actual impact? Or basically, what does the money trading look like?
Mm-hmm. No, yeah, that's a fair question. So it comes in different forms. So some of these are, so let me take this Los Angeles deployment, for example, is something where we partnered with UCI, and they partner with SCAG to do this model. And actually there's a fleet partner involved in that as well, to develop this model and deploy this model. But the funding is really to do this as a part of a research grant, right? So there's a project there. There's actually two projects there. There's one looking at regional freight delivery and one exploring vehicle connectivity and traffic control strategies. But that's an example of a model that's developed with local partners driven for a specific research outcome. Dallas and Atlanta, in contrast, are actually DOE-funded projects where they want us explicitly work with this MPO, try to get the tool in their hands, get their staff trained up and able to use it and deploy it for specific studies, and get feedback on what does the tool need. So this is more like a beta testing of the tool as a deployable platform that can go out and get into MPO hands. So the funding there is for the tool improvement. Some of the models we work, we have an interest in doing our R&D studies, around certain areas like Chicago, Austin, Detroit, and so on. So we go and develop partnerships with those MPOs to get access to the data, and for them to provide reviews. CMAP will say this makes sense, this doesn't make sense, this is a strategy of interest. So that is more driven by our research needs. We would like to develop a program where, if you have research needs, you come to us, and we can deploy the model. We can help, and maybe an MPO or a state or something can support more directly. So when it's a DOE funded, it has to be serving. They obviously care about the end user priorities, but it also has to be something that would satisfy their priorities as well. Where if it's more direct funding from whatever agency would be interested, it could be more driven by agency priorities. And CMAP, the Chicago model has somewhat evolved to that direction in that we now have a project directly with CMAP to do regional decarbonization planning, where their priorities are obviously taken into account. So there's a lot of different ways that this can go. Whether it's an interesting R&D question, then we target R&D funding. If it's an interesting, is there something we could do for deployment, then maybe it's direct funding. But yeah, we're pretty open and pretty flexible in terms of how we'd like to get this tool out into people's hands.
Great. Yeah. Again, I have lots of questions. So I have two other questions, a little more technical as opposed to like policy funding. But I'll pause since I've been holding the mic. But I do have two more technical questions if there's time.
I don't see any other questions. So.
Sure. So one thing in our current, in our design that we're really interested in. This is a good slide for that. I appreciate you clicking back to this slide just to knowing where I was going somehow. One place that we're focusing a lot of our interest and trying to improve our modeling capabilities is around better representing how people make bike choices, specifically, and trying to represent how comfortable individuals are, and not assuming that every individual will get on a bike if they are given the infrastructure, but identifying that some people, for different reasons, won't get on, would never take a bike under any situation. Anyways, just as an example, but I'm just curious, what if any of these cubes have to do with improving active mode representation, or just kind of like, well, what have you done to maybe push the research when it comes to biking and walking?
Yeah, a lot of that. So let me step back. There are aspects of bike ownership and bike use within a few of these cubes. So we do have it as vehicle choice, but I should maybe it's been a while since I've updated these slides, but that's more like mobility choice. So within the long run decision making that the households engage in the simulator, it is, how many vehicles do I want to hold, but also, do I or anyone in the household own a transit pass? How many bikes do we own? Do we want to, do we engage in membership in one of the shared ride? Do we sign up for one of the shared ride apps? Do we sign up for e-scooter or shared bike systems? So it's more of these like long run mobility choices that are factored in there, and then that flows down to the mode choices, right? So if I own bikes, I can choose bike as a mode, and we observe bike in the mode choice data that we collect from a lot of the household travel surveys, and then we're trying to improve that with a lot of the data from the bike share system and a bike from the e-scooter system, which are not exactly the same as using my personal bike, but we try to incorporate like what are the motivating factors and how does infrastructure land use mix, right? So that's another big thing is, do I want to how a place looks and how interesting a place is to bike through, how, you know, what is the safety factor and the tree cover and weather. Like all of these are things we're not perfectly representing right now, but actively trying to extend to. And I think one of the biggest gaps, and one of the one we want to try to address sooner than later, is the, so we, you know, e-scooter and e-bike from a shared bike system show up a lot in the data, but personal e-bikes I think is an expansion, and really even from you know, knowing my you know, parents getting older and other people's, you know, the adoption of these e-bikes really does influence the use of that mode. And there's sort of a data gap around that, at least that we've seen. So that's another area. But active area, and I think a very interesting area of research, because we do try to represent that in quite an extensive level of detail in the network routing side. So, you know, we have all the, whether it's a docked bike, you know, we have the docks. If it's a dockless system, you know, we track where they're sitting, where they're being rebalanced. So are the you know, is the operator agent actually moving a bike from one place to another due to an imbalance in you know, between the supply and the demand? But yeah, good handle on that. Less good handle on the private bike side. It's really right now just we own a bike, so it's available. So yeah, agree it's a gap, and agree it's an interesting gap.
Yeah, well, even that's pretty good that you're representing whether or not they own a bike as opposed to just all people bike. And I like the idea that you're at least starting with, do they even own a bike? And there's some representation, like there's probably something there about choosing the right people that even own bikes. That's great that you've got that. I've got more, but Aaron has his hand up, so I will pause.
Hi, Aaron Breakstone, Portland Metro. I'm a little curious about the network modeling. I noticed AIMSUN listed as one of the project partners. Is it their multi-resolution platform that's built into this, or something else?
AIMSUN was a partner on this project, and sorry, AIMSUN was not a partner. AIMSUN was the tool that was used by our Berkeley lab partners, who were doing a lot of the detail traffic flow simulation with different vehicle technology deployments. So the component of AIMSUN that was used here was actually the micro simulation. So the Berkeley Path team had, I think it was a Contra Costa and Walnut Creek. There's a few different areas within California that they've micro simulated in fairly extensive detail, and have actually done field deployments of some of the automated vehicle technologies. So those field data findings were flowing into our network model, but our network model itself doesn't use any components of AIMSUN.
Okay. And am I correct in assuming that there's sort of it's multi-resolution and there are handoff between different scales at different steps in the model flow?
That's actually a very interesting question, and is our current workflow for this year. So multi-resolution traffic flow modeling is actually something we're having our first deployment of in this month, and reporting out in the next couple of months to connect to. So we have a deployment partner in the Chicago area looking at, you know, detailed corridor level deployment of you know, connected signals and things like this, where we want a detailed representation of that through actually still deciding if that's Sumo or you know, off the shelf software, but detailed micro simulation that then connects directly to the Polaris, which is more of a meso to micro type simulation. So that's something in the works, but will be deployed shortly.
Got it. Great, thank you.
But yeah, in general, the resolution throughout, like just the base simulator is usually around you know, 1 second, second by second network movements.
Great, thanks.
Looks like there's another hand up.
Yeah, good morning. Thanks for this presentation. It's a pretty impressive tool. I guess I'm building off of where you were going with Alex a little bit about how it's trying, you know, it's a research tool in a lot of ways. It's, you know, because of its sort of heavy footprint there, but it might be able to help, you know, some of the questions that our traditional tools don't. So you guys, you know, some of the insights that you've already shared in this presentation, is that shared out in any way? Is there a place where you're keeping some of this information? And then if we had particular questions, you know, hey, we're struggling with this input in our model that we can't, you know, exhaustively look at, but you might, you know, look at the 5 or 6 models you have and give us sort of a pretty good range to put in our model, for instance, that might not be specific to our area, but could really, you know, at least give us a pretty reasonable range for some assumptions.
Yeah, I would say we try to be pretty. I don't know, that looks cut off a little bit. We try to be pretty proactive about publishing everything that we do. So there are papers on almost every aspect of the model, maybe not some of the newer things we've been adding, which are, sort of in the works to publish, but we do try to have everything online. So all the papers we publish are available on OSTI.gov. So the U.S. government funded research site. References to those are available on our website. I don't know, Murthy, if you want to put well, I guess someone found the license there, so maybe it's in the chat already, but we do try not to have anything held back in terms of what the models look like. We describe how all the models are estimated and what the actual models that go into Polaris itself are, and any of the studies that we run. So even the sort of large scale Chicago area study that should be a paper coming out, well, hopefully it was submitted for presentation in the next couple of months, so we'll see when reviews come back. But yeah, all of this can be shared for sure.
And
always
a lot
happy
of it's,
to. Sorry, go ahead.
Right. Yeah, that's maybe where you're going too. Like, help point us to which one might be relevant to a question that we're asking. Would that maybe be through the forum, the library? Well, that's just going to be a listing as well. Just wondering, if you guys are, operating at all like a sort of resource to help point people to studies that might be relevant. So, because there's a lot of information. A lot of it is more background of how you arrived at the tools. And I'm really looking for those nuggets of gold and, in particular as questions come up or, yeah.
One thing we did, and let's see, to address that point, and I think it's probably a resource online we can pull up. I don't know, Murthy, if we can find a reference to it, but when we were wrapping in the second and third year of our previous research program under Smart Mobility, there was an effort to engage in occasional webinars. So I think it was every month we were trying to pull out, as you say, what is the nugget? What is the detailed research? What is the research highlight that's interesting, relevant, impactful in various areas? So there is a webinar focused around shared mobility. There's a webinar focused around electrification. I think there was one on vehicle controls and system level controls. So we did try to bundle up what are the research highlights with appropriate references. I think in the end, or I guess the papers that Murthy shared could reference that. But that was like what are the impactful findings that are relevant to communicate to stakeholders. And I think that is a process we'd probably like to continue, just to have occasional webinars. And more, I think more directly to your point, we're trying to implement something in the coming months that is more of like a forum to where people can ask questions about our research, but also we try to participate in other forums. So we try to participate in that webinar forum. We try to get to as many conferences as we can to present highlights. So yeah, we're always working to improve to make, everyone wants to make sure that the things they do are impactful and helpful for others. So to the extent we can do that, I think we're happy to do so.
Great. Yeah. I mean, I think you have a more comprehensive look in this model than most do. So it like you're saying, if you just look at one thing in isolation, it might, miss some of the broader things. So, and I know a lot of this is very context sensitive, right? So transferability is always somewhat questionable, but I think we're largely grappling with how to think better about things. And so knowing that, hey, that could happen, maybe we should be testing it in our worlds as well. So I think, you're just highlighting these nuggets that we may not be aware of in our tools as we're running them, and that we should be more broadly aware and maybe look into in our context if it's an important thing. So appreciate that. I really like that idea of the focused those monthly webinars by topic, right? Because I think that's where people show up and say, well, I'm working on this topic, so what do I need to know that maybe I don't already know in a broader context?
Yeah, no, agreed. Definitely something we're pushing on. And I think, I don't know, Murthy, if you put a link in there, but we are trying to organize. So one thing we started last year and trying to carry into this year is to like user groups for who's using Polaris, what have they found out of it? So try to get that feedback from the actual users of the tool of what works, what doesn't, what was interesting, what is the cutting edge research you're doing with it. And that's something we're trying to organize for this May if there's interest as well. It's kind of a 3-day workshop just to sit and get some of the background of the tool, but mostly, get people's experiences with it.
Great, thanks.
Yeah, and the extent, I guess, just to build on one other, not to take too much of the time, but to build on one other point you made, how do things vary? So even under the context of limited transferability and not always certain that a model in one context will work in another, we did run as a part of this program a comparative analysis between 3 different cities, sorry. So we ran kind of similar to what I showed for the Chicago large scale study here. So slightly fewer levers. So I think it was 64 different scenarios for 3 different cities. So that was Chicago, Austin, and Atlanta. And even there, so things are slightly localized, slightly calibrated to their local travel surveys, but we didn't re-estimate every model for every city. You do see quite different impacts just based on the local context, how the network is organized, how frequent transit is, what different industries people are working in. So you can pull some of those nuggets and say, what works in Chicago doesn't necessarily work in Austin. What works in Atlanta definitely doesn't work in Chicago and Austin. So there's even in that limited transferability scenario, still some interesting findings you can get out of comparative analysis. And I think that did show up in one of those webinars too, if we find a link to that. Oh, sorry, I answered a question for Becky Knudsen in the chat, but forgot to hit the check mark. So I'll just mention quickly that freight analysis framework is one source of the commodity flows that we use in the freight model. I don't know if there was a follow-up on that or not. Okay, yep. And FAF, I think going into the 5th version of that. So useful to update 5th or 6th, I forget. But yeah, that's definitely a source that the freight team uses.
I just had, this is Alex, I just had one more clarification. I was when we were talking about the trends around how EVs impact the amount of travel. We talked about charging and how long distance travel might be impacted. One of the things that one of the changes that we've been looking at that it's impactful is understanding how the electricity is much cheaper than gas currently. And so it's cheaper per mile to travel in an EV versus ICE. So as you get, as you push towards 80-100% of the fleet EVs out in the future, you have a pretty different across the population cost to travel. So as you were answering that question, I was listening to see if any of that was in there, and I didn't hear it. So if you could clarify whether or not that calculus is happening with electric vehicles.
Yeah, thanks. I forgot to mention that point. That is one of the findings we pushed back to our sponsors after this study. And they're like, oh, that's interesting. Yeah, is that the vehicle, the operating? So we do have for each household their vehicle type, so we know which households are running, a hybrid or a plug-in hybrid or the EV. Each vehicle type in the simulation has different operating costs, which is basically an outcome of the autonomy model. So it's a performance and cost. So we do know how much reduction there is in the edge cost when they're routing and the travel cost when they're selecting destinations. So there is it's not the controlling factor for these decisions, but it does influence marginally, right? So if you reduce the cost of something, it's going to consume more. So they do travel slightly further for that reason as well. We typically find that the travel time cost is the more limiting factor, but the operating cost is, if you cut the operating cost in half, it's not going to double the travel distance, but it does increase it. So yeah, that's a good point. That's something we found in that study.
Thanks.
Another question?
Yeah, this is Tara from ODOT Climate Office again. Wondering if you've done any repricing studies. I know Alan, forget Alan's last name, FHWA is doing some work kind of more economically with, shifting costs into per mile. So costs of, pay-as-you-drive insurance, registration fees, and so forth into per mile, and how that has a behavioral impact. Wonder if you've done anything on that front or coordinated with that research.
The one we did a study along those lines that was sort of jointly between us, a team from Federal Highway and EPA. So they were using the GCAM tool, which is sort of a high-level strategic analysis for decarbonization policies and other strategies. So it sets energy pricing. Basically, it's I don't have a perfect understanding of this tool, but it does scenario analysis for different policy interventions. So if we want to charge a carbon price or subsidize EVs, I believe it tells you what the fleet mix and the operating costs and so on look like for that. So we did run a scenario that was a version. Actually, I showed a version of this with the Austin land use and CACC impact study. We said, can we do something with carbon pricing to mitigate some of the downside impacts of the vehicle automation? And we did find that, yeah, if you sort of internalize, add cost of carbon into the driving, it does reduce some of that impact. So it's not directly repricing. We've done other pricing studies to, let's say, Murthy, I think this was one that you all were involved in with the dynamic pricing, but not per mile, but actually per delay imposed. So it was more like a trying to calculate a system optimal congestion pricing in Austin, and that was also found to be a fairly effective policy. And that's where you look at the marginal impact of every vehicle and try to internalize that as a toll they pay to make those decisions to guide it to more system optimal solutions for routing.
Probably have time for one last question from Aaron.
Hi, thanks. I know we're short on time, so I'll keep it brief. I saw a pretty interesting presentation at TRB by your colleagues at the Berkeley lab on the beam model. Can you, at very high level, talk about, how those two fit together? Are they on parallel tracks? Are there key differences between the two?
Yeah, they're basically parallel modeling efforts from the Department of Energy. So it's sort of let's say a strategy to stimulate competition and some cooperation between these models to say, they didn't want to basically predetermine that this is the strategy to follow. So there are slight differences, or let's say substantial differences, not slight differences in terms of the frameworks being deployed. So Beam is more of, it basically comes out of the MATSIM framework. Which is sort of the replan optimization. So come up with a day pattern, replan it, come up with a day pattern, replan it until you come to some type of convergence, where ours is more of the sort of bottom-up agent-driven solution. So they're getting at different solution patterns. They have different run characteristics, different capabilities. But yeah, they are two parallel efforts.
Great, thanks.
So we're almost out of time here, but not to put the two guys on the spot, but our webinar today, or our session today, came about because of Ray Jackson and Matt Bin, who I think ran into you guys at TRB. So I didn't want to leave the meeting today without acknowledging them for bringing you guys to us, and then seeing if either of them wanted to offer any parting shots.
Hi, this is Matt. Yeah, we were put in touch with these guys actually through Kung-Hwa Kim, who worked at Metro for a long time and is in Atlanta. And for us, I mean, obviously we're committed to activity sim, but we are interested in anything that develops modeling and helps research and development. So I think we see this more as like an opportunity to help out someone. We're not looking to, immediately replace what we're doing and so we thought bring it to OMSC just so everyone can hear what, the presentation, and also just transparency on our part and what we're up to. So we haven't even really met other than, in person for 5 minutes at TRB and then this presentation. So we'll have to meet and see. We don't know what, like if we work together for, some kind of research capacity, what the needs are, what kind of hours that would require on our part. So, but I just wanted to let everybody know that's just we've just barely met, and we thought it's interesting, and so it's an opportunity for people to learn what's going on nationally. And thank you for coming. It's interesting.
A lot to chew on.
Thank you so much.
Well, yeah, thank you, and definitely we are very excited to follow up. We have a strong interest, especially in the statewide and larger regional modeling, and if there are things we can do or ways we can work together, or even just learn from each other, based on the survey that that you mentioned is being collected and some of the research outcomes from that. We are more than happy to follow up and schedule different visits or even a visit out there. Just let us know. And I think we shared most of the resources. We're happy to share the slides as well. And thanks again for the invite and the opportunity to present here.
Thank you, guys.
Maybe one final
Yeah.
plug that we have a Polaris-based workshop coming up in May, but so I hope I can use the email list and send you all some information about that shortly, in case you all are interested in coming to Chicago for a 3-day workshop on this topic.
That'd be great.
Thank
Thank
you.
you all.
Thank you.
Thank you.
Thank you.
Take care.